Okay, this is question number 1 off of Unit 3, Worksheet 4. How much energy must be absorbed by a 150-gram sample of ice at 0 degrees Celsius that melts and then warms to 25 degrees Celsius? Now, when you get a problem, you might want to read it a couple times just so you know what it's asking you. Another good technique is to underline or circle keywords, or you can just simply list them below. So what we're trying to find is energy. And in our equations, we know that energy is represented by Q. And this energy is being absorbed by a 150-gram sample of ice. So now I know that 150 grams must be my mass. And this is at 0 degrees Celsius. So my starting temperature is 0 degrees Celsius. This ice is going to melt and then warm up to 25 degrees Celsius. So I have two different processes that are happening. My ice is first going to melt, which means it's going from a solid to a liquid, and that's a phase change. Once it turns into a liquid, it needs to warm up to 25 degrees Celsius. One thing that you do need to know coming into these problems are what the boiling point and melting point of water is. For water, the melting point is 0 degrees Celsius. So I know that right away this ice is going to melt because it's already at 0 degrees Celsius. So if I were to do a heating curve of the situation, I can start my heating curve at 0, and at 0 it's going to go from a solid to a liquid. My second step is that the liquid is going to warm up to 25 degrees Celsius. That means in my second step I have a temperature change. I'm trying to find my overall energy from when it starts as ice to when it warms up to 25 degrees Celsius as a liquid. So I have to split my problem into two chunks. I first need to find what my Q is, how much energy is needed to melt the ice, and then I need to find out how much energy is absorbed by the water as it warms up to 25. So let's break down the solid to liquid chunk. If I have a phase change, that means my temperature is staying constant. It's not going to change. So I'm going to go ahead and use my equation Q equals mH. To figure out what heat of either fusion or vaporization I'm going to use, I need to know what my phase change is. If I'm going from a solid to a liquid, I'm going to have to use my heat of fusion. In this case, it's my heat of fusion of water. So, keeping that in mind, my mass is 150 grams. And looking at your notes, you will find that your heat of fusion of water is 334 joules for every gram. So I have to multiply my heat of fusion by my mass, and I should get 50,100 joules of energy. That's the amount of energy needed to just melt that ice. We now have to find how much energy is needed to warm that liquid up until about room temperature. So since we have a temperature change from here to here, we have to use the equation that has a temperature change in it. And the only equation we have is Q equals mc delta T. So let's find out that Q. Our mass is 150 grams. This little c here is going to be the specific heat of liquid water because we're warming up liquid water. The specific heat of liquid water is 4.18 joules for every gram degrees Celsius. Now my change in temperature is going to be my final temperature minus my starting temperature. So I'm going to take 25 minus 0 degrees Celsius, which will end up being 25 degrees Celsius. Multiplying this out, you should get 15,700 joules of energy. That is the amount of energy that's required to warm this liquid from 0 degrees Celsius to 25 degrees Celsius. Now, referring back to the question, it wants us to find the entire energy that's absorbed when melting and warming this liquid. So I have to add up both of my energies. So my third step is to take my first energy required to melt the ice, 50,100 joules, and add it to the amount of energy needed to warm up my liquid water. You should get roughly 65,800 joules of energy.